that one. So this is odd and negative, just to practice from yesterday a little bit. Now we're going to look at some specific points on graphs today, and I'm either going to give you a picture of the graph with those points indicated, or I'm going to ask you to look at them. Either we're going to do it today on Desmos. We'll do it a little bit when we come back from break on a graphing calculator. But what we have here are 2 points that are called the relative maximum and the relative minimum. So anytime you have an odd degree polynomial, one side will go up forever, one side will go down forever, but we have kind of some points in here where they kind of, it almost looks like either the bottom or the top of a parabola, right? So those are called, if you want to jot this down, like where I switch from increasing to decreasing or decreasing to increasing, those are called, that's called a turning point. So I've got 2 of them in that graph, but where the graph changes, like on one side, if I look at the one I highlighted in yellow, like my y value is going down, 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 and then I turn and I start going up. So those are called a turning point. And that is where you can have what we call a relative maximum or minimum. So for an odd function, that's kind of a typical picture. And it's called a relative maximum because really one side of the graph goes up forever to positive infinity. So it's relative on this domain that you're looking at. This is a little maximum right here. Same thing. This goes down forever, so I don't have a minimum for the graph because it goes to negative infinity, but we have what we call a relative minimum. So those definitions are up there at the top for you. The only thing I wanted to point out, it is just the y value of that point. It's not going to be the x value, it's just going to be the y value of that point. So we'll talk about that when we have some actual examples with some numbers on there. Now, the other graph, bless you, the other graph I have, this one, both ends point down. And I know there's a lot going on in that graph just in the picture there, but both ends point down. So this has to be an even degree. And since they're going down, it has to be negative. Now, if you have an even polynomial, even degree, then you're going to have a couple different options. So I still have what I call a relative maximum and a relative minimum. But then you can also have what we call an absolute maximum or minimum. So in this particular graph, the 2 end behaviors go down forever, right? So I go down to negative infinity. But if I look here, this point, right, kind of highlighted with my blue highlighter, that is absolutely the top of the graph. Everything is below that. So if you have an even function, you can have what we call an absolute maximum or an absolute minimum, but not both on the same graph. And it tells you right underneath here, it says no absolute minimum because the 2 ends go down to negative infinity. So just for absolute max and min, just to kind of add this in, absolute maximum, greatest y value of the entire graph. So that would be what I have in this little picture, but it doesn't exist if the end behavior goes up on both ends. So that doesn't exist. Absolute minimum, you don't see that in the picture. We'll do that in one of our examples. But an absolute minimum doesn't exist if the end behavior goes down on both ends. So absolute maximum or minimum are only going to exist if you have an even degree polynomial. And then it just says down here, absolute max and min don't exist if the end behavior goes to infinity and negative infinity for any odd function. One side goes up forever, one side goes down forever, so they don't have an absolute maximum or minimum for any odds. All right, so I'm just going to draw on these 3 little graphs to tell you what I've got going on here. All right, if it's odd, opposite direction, this goes up to positive infinity, this goes down to negative infinity, so no absolute maximum or min. This point right here, I'm just kind of sketching on it. That would be what we would call a relative maximum. So I'm just going to write relative max there. Turns, and it goes, one side's increasing, one side's decreasing. So it's a turning point, but that's a relative maximum because it's kind of at the top. This one down here, that would be what we call a relative minimum because it's a turning point in the graph. But on that window that I have there, that's a relative minimum. Now, if you look at this one next to this is just a parabola. this does not have relative max or min. This just has, this would be called an absolute minimum, because that the vertex of that parabola is absolutely the bottom of that graph. There's nothing below that. So just an absolute minimum there. And then this last graph is a little tricky. So there are kind of 3 points I'm going to try to draw on. These two are like really close to each other. But this is going to be an absolute maximum. That point is literally the top of the graph because the arrows both point down on the bottom of that graph. So there's nothing above that. Now, there's 2 turning points here. They're really close to each other. So one here and one here. This one, where it's kind of, it's almost like for relative max or min, it's like the top of an upside down parabola. So that little, where it bumps up, this would be a relative maximum for that graph. And then here, where it curves underneath, that point would be a relative minimum for that graph. So we're going to actually identify these specific points on some graphs in the first example here in a second. So, is anybody having a question at the moment? Okay, it's not terrible to do. Now, I stole this from Desmos, and I just clicked on all the points that we might need to answer some of these questions. So, I'm going to ask you just a little throwback for domain and range here. So if I'm talking about the domain, I'm talking about my possible x values from the graph, I'm going to write a little interval for this. We're going to go from left to right. And then for the range, that's your possible y value. So I'm going to go from the bottom to the top. Does anybody know, like, just raise your hand and tell me, what are the possible x values for this graph? Like, if I'm going from left to right, what would the interval be to describe the domain here? Like, what's the first x value I touch? What's the last x value I touch, if you're thinking about it? Right, there's an arrow here. Like, I touched a 5, but there's an arrow. This would be going down, like, to the left forever. This would be going, like, up to the right forever. Oh, yeah, she did. Lights on. Negative infinity to infinity. I know that's super tricky because this looks like it goes straight down, but it does go to the left, and this side almost looks like it goes straight up, but it does gradually go to the right forever. You would cover the whole x-axis. That domain is true for any odd degree polynomial. What about the range? Like, what am I doing up and down there? What would you write for your interval for your range? Possible y values. Okay. Same, right. One side, this side goes down to negative infinity, right? This side goes up, so you cover the whole y-axis. So negative infinity to infinity. These should be the domain and range for, bless you, any odd degree polynomial. You're going to cover the whole x-axis, the whole y-axis. Okay, now I know you guys could identify the zeros, so I'm just going to go along here, write down where the graph crosses or touches the x-axis. You don't have to write the points. I'm just going to write like -5, -2, and 3. That's all you have to do. Where would I find the y-intercept for the graph? Or what point would that be on that picture? Hold my thing. Yes. So y-intercept is just where your graph crosses or touches the y-axis. So x-coordinate should always be 0 at that point. So it would be 0, -30. Okay. Now, I'm going to kind of do this out of order just a little bit. Because one side of this graph goes down forever and one side of this graph goes up forever. Whenever you have an odd degree polynomial, you do not have an absolute maximum or an absolute minimum. They don't exist. Because one side goes up to positive infinity, one side goes down to negative infinity, not to a specific number. So no absolute max or min on this graph. Now, the relative max or min, you have to tell me the y value, and I'll show you how to write this. Does anybody know the y value of the point where the relative maximum would be? Like, what would the y-coordinate be? What do you think? Heck yeah, all right. That's at 14.815. Now, I just want the y-coordinate there. So, this point, relative maximum right there. Let's jot that down. That's my relative maximum. Now, the way you write this, and I know this is kind of weird, so the actual relative maximum is the y value, and you say, I'm going to write this underneath, at x equals whatever that x coordinate of the point is. So the relative maximum occurs at the x value of negative 3.667. Sorry, Desmos does this to 3 decimal places, so a lot of these points will have 3 decimal places. So I'm just going to go ahead and write that out. That's your relative max. What would the relative minimum be on this graph? What do you think? Yes. Okay, so the relative minimum, these occur at a turning point. So this is like I'm decreasing, then I'm increasing. So there's your relative min. And it's just going to be the negative. This one's actually a nice point, negative 36. And that happens at the x value of 1. So negative 36 is the relative minimum. That happens at the x value of 1. Okay. Now, the other thing we're going to do here real quick is describe the intervals where the graph is increasing or decreasing, but that's perfect because it should change over at where we had our relative max and min. So I'm just going to grab a color here. Okay, when you do increasing or decreasing, and I maybe should remind you guys of this, these should be x values because you're going across the domain. So increasing and decreasing, we're not talking about any y values here. These should be x values. Now, I'm literally just going to trace this with my marker to kind of highlight what's going on here. So, go from left to right. This entire time, my y values are increasing, increasing, increasing until I get to that relative maximum. Then that's why it's called a turning point, because I changed from increasing to decreasing. So then I'm decreasing, decreasing here. And then I'm going to switch over at that relative minimum. That's a different turning point. Increasing, increasing. So I have 2 intervals that are increasing and 1 that is decreasing. Now, all I'm going to do, go from left to right, and if this helps anybody in any way, where is my pen? All the way to the left would be negative infinity, right? All the way to the right would be positive infinity. So I'm traveling from left to right. This entire time I would be tracing the y values to go up. So they'd be increasing. So for my increasing, that's going to go from negative infinity till I get to that turning point, and you just want to grab the x coordinate there. So negative 3.667. Now, at that same point, that's where I turn, and I start going decreasing, down, 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 down. These y values are going down. So you're going to start up there. We're using parentheses. So negative 3.667 until I get to this point, and I want the x value. So at the 1, then we're going to turn, and we're going to start increasing again. So if you have more than one interval that's increasing or decreasing, you just put that little union symbol in between, just means there's more than one. So now at 1, the rest of the graph, as I go, I know I'm going up, but as I go to the right forever, the rest of that graph is increasing. So it's just 1 to positive infinity for the interval. Does anybody have a question? Now, on the back, we're just going to do, that was an odd degree polynomial, so I'm going to do an even degree polynomial with you here on the back. What would you tell me for your domain for this picture? Like left to right, what are my possible x values here? What do you think? What is my possible domain? So like this is going up and left, this is going up and right. I know it almost looks like it goes vertical. What are my possible x values there? For sure. All these polynomials, their domain should be negative infinity to infinity. Now, if you're working with an even degree, which we've got here because both ends point the same direction, the even degree, the range is not going to be negative infinity to infinity. So if I approach this graph from the bottom, like I'm not touching any part of the graph until I get to this point right here, right at the bottom. And then remember, for your range, you want to grab the y value. So the y value of that very bottom of that graph is that negative, sorry, it's too many decimal places, negative 45.335. That would have a bracket because I actually touched that point. And then the rest of the graph just points up forever. So the range would go from that negative 45 up to positive infinity. Sorry, that's really close to the staple there. All right, for your zeros, I'm just going to go across the x-axis. So I got negative 2, I've got 0, and I've got 4. this is super tricky. Can anybody tell me what the y-intercept is for this question? It is, yeah, I know that's weird, but it's actually the origin at 0, 0. All right, now, I'm going to kind of skip around here a little bit. Your absolute maximum does not exist for this question because both the end behaviors go up to positive infinity, so no absolute maximum. Now, my absolutely minimum does exist on this graph. The very bottom of this graph, if you have an absolute max or min with an even degree polynomial, it should just match up with the range. So my absolute minimum here, remember I just want the y value, the lowest point on the graph, it's negative 45.335, and I'm going to say that occurs at x equals 2.886. That's the absolute bottom of that graph. All right, so this is a turning point here. I have two other turning points in this graph, and these should create your relative max and min. So relative max, I know this is weird, is actually going to be the origin. And the relative minimum is actually going to be this point right here. Now, absolute minimum, kind of like the bottom of a parabola, all the way at the bottom. This is a relative minimum. It's still at the bottom of the parabola, but it's not as low as this. So this is a relative minimum. This is an absolute minimum. So that's the difference there. And then I'm just going to jot down those values real quick. So my relative max is actually just 0 at x equals 0. So the y-coordinate and the x-coordinate end up being the same on that point. And your relative minimum, remember I'm writing down the y-coordinate, it's that negative 6.353, and that occurs at x equals negative 1.386. All right, now this one will be a little bit trickier for intervals of increasing and decreasing because it's a higher degree polynomial, so there's more intervals of increasing and decreasing. So if I'm going to draw on this real quick, all the way to the left forever, I would be drawing down, 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 so that little first piece is decreasing. You get to the turning point, and this is super small here, but just for this little piece, my y values are increasing, and then I get to that turning point at the origin. This is decreasing, decreasing, decreasing. My y values are going down, 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 and then I've got that turning point, my absolute minimum down there. Then I turn, and the rest of the graph goes up to positive infinity. Okay, now when I'm describing this, we're doing x values. So we're going from left to right. So as I'm traveling here, I would be drawn down, down, down on this graph until I get to that turning point. So that's decreasing. And forgive, I didn't space this out very well. So the intervals where it's decreasing, you're going from negative infinity to that relative minimum, which is x values negative 1.386. Okay, now at that same x value, then we're turning and we're going to increase for just a tiny bit. So that negative 1.386, and then until I get to the origin, which has an x-coordinate of 0. Then I'm going to decrease again. So it should start up at that same number. I'm just going to put a little union symbol in between 0, and then all the way down here until I get to that 2.886. And then I'm going to come back up here, same 2.886. We turn, and then we start increasing. And now I know this is tricky because it's going up, but I'm talking about as I go to the right when I'm describing this. So all the way for the rest of the graph to the right, as I go to infinity, the graph will be increasing. Yeah. Nothing for increasing, decreasing. Brackets would only be for the range. Okay, now I'm glad she asked that. So the reason I'm not using brackets on these, when you're at that actual turning point, you're flat. So like if I'm at this negative 1.386, I am not increasing or decreasing. That's where I'm turning. So that's where you use a parenthesis instead of a bracket. I'm glad you said that because I forgot to remind you guys of that. Okay. Is anybody having a question? All right, for these last two, we're going to use Desmos. So if you guys already have your computer out, I'm going to see if I can pull mine up on the screen at the same time. So this is just going to ask you to do two things. Zeros and then the relative max or min for the graph. So we're just going to practice doing this without me giving it to you first. So if you go to Desmos desmos.com. If you need a link for it, it's in the Canvas homepage here. And I'm going to pull this to the side a little bit so I can copy that equation in there. If this isn't the screen it took you to, here, I'll tell you what. If you just go to desmos.com, the screen looks a little bit different. Looks something like this. Just click on the little button that says Graphing Calculator, then it should take you right to that screen so we can graph. So I'm just going to copy. Now, you do need to put in like the y equals. So I'm going to write y equals, and then x cubed. Do you guys remember how to do an exponent? Shift 6, shift, and then the number 6 will give you an exponent. I am going to use the arrow key to get out of the exponent, and then I'm going to put plus 4x, and then minus, 4x squared, fail, 4x squared, and then minus 5x. And then if you guys want, I'm just going to do this on my screen so I can see the graph better, but if you click on those little double arrows there, that'll hide that so you can see the graph a little bit better. And you can, I just grab, if you just like kind of scrunch with your fingers, you can move around. I just kind of grab the y-axis, like pull it down together, or I can grab the x-axis. Basically, I just want to see the critical points on the graph. And I know it's been a minute since we've used this, but if you just take your mouse, if you just kind of click on the graph, you can click on these points and it'll hold it on the screen so you can see it. And I'm just clicking on each one of these. It'll make the point kind of a grayish color on your screen, I think. And then if I click on it, it'll keep the information about the point right on the screen for me. So if I have to list my zeros here, I'm just looking at the graph, right? I've got -5, 0, and 1. So those are all nice for that example. And then it asks you to list the relative maximum, and it asks you to list the relative minimum. This graph will have both because this is odd. What number would you tell me is the relative maximum on your graph? Or do I have one? Maybe I don't have one. You guys have the same graph I do? Or did I type it wrong? Okay. What number on that graph is the relative maximum? Okay. Yeah, we got the same number. You guys not see? Okay, I'll just tell you real quick. Should be the relative maximum is going to be that 24.193. And I'm going to say at x equals that -3.189 on the screen there. If you guys need help moving the screen around, I can help you with that. I'll come around in a second. Okay, now the relative minimum would be like the bottom of the parabola here. So this would be that point right here. And sorry, sometimes these points have a lot of decimals. I'm just going to go ahead and write them out. So this is -1.378 at the x value of 0.523. That's all you have to write. You don't have to do increasing or decreasing or anything like that. Just filling that in. I just want you guys to be able to practice that and be able to get that for yourself instead of me providing you with the graph. Is anybody having a question or having trouble with the Desmos? Okay, I'm going to click these double arrows again real quick, and I'm going to pull up this one. Okay, so now this one is also an odd function, but this one's negative. So this is -x cubed, and then I've got plus 16x squared, minus 76x, and then plus 96. So this actually has 4 terms. Make sure you have the y equals out in front, and I'm just going to close that so I can see, and I'm just going to drag. Actually, that's a decent screen for that. So I'm just going to come over here. I'm just going to click on my zeros so I can see what they are. You might be able to tell from just looking at the graph. And then I'm going to click on the points where I have a relative maximum or minimum. All right, so for my zeros, what we have here, we got 2, 6, and 8. And for my relative maximum, let's see, it's just kind of like at the top of like an upside down parabola. So I'm looking at that point right there, 5.0. 5.049 at my x value of 7.097. That's my relative maximum. And then my relative minimum, that's going to look like it's at the bottom of the right side up parabola, so we're looking at that point right there. So it's going to be that negative, we want the y value for this, negative 16.901, and our x value there is 3.565. I'm not on the screen fired. Okay, is anybody having a question? You just click on it, like with you. I usually click on it with the mouse. I don't know if it'll work with